Okay. Now, what it amounts to is that when x equals 1, the value of this function is 0, the value of this function is 1. Well, actually, let's start here. When x is 2, the value of this function can be represented, wrong color, by this arrow, right? This is the value of f of x when x equals 2. So, we'll just say that's the value of f of 2. Okay? And where's the value of g of 2?
4.
Well, the value of the function is always so there's a little arrow right here that you can't even see, little arrow from here up to from the x-axis up to the purple curve. That's the value of g of 2, right? So if I add that little value of g of 2 to the value of f of 2, okay? Well, we've got a small purple arrow on top of a much bigger yellow arrow, but we get the value of h of 2, okay? So I can kind of depict that over here away from the graph. If this is f of 2, and this is g of 2, then this is the value of h of 2 equals f of 2 plus g of 2. Okay? So let me illustrate this just for a couple of arbitrary functions where it's going to be easier to see. But before I do that, let's just say, okay, as x gets bigger, the value of this function gets really tiny, right? Which means that the values of h of x, which I'm depicting in orange, are going to be pretty close just to the values of f of x. Which means we're going to be just adding really tiny values here, so the further we go out, the closer these values become to the graph of the f of x function, because the h of x values are practically 0. So we're adding almost nothing to the f of x function when we're out here. On the other hand, as f of x gets close to 0, we're adding essentially nothing. Well, we're adding actually nothing at this point to the value of the h of x, or the g of x function. So that our h of x function, at least between here and here, is going to pretty much look like this. And by the time we get to this, it's just pretty much going to run along with the f of x function. So we say that the h of x function is asymptotic to the f of x function as x gets big. And that's because our g of x function approaches 0. Now, to the left of here it gets more subtle, and I'm not even going to attempt to do that except to say, well, if this is the point where this one is as high as this one is low, then the graph is going to continue to here. And then because of behaviors that we don't want to talk about just yet with the inverse of the exponential function, this thing gets much lower than this so that the graph just kind of goes off like this and it becomes asymptotic to the negative y-axis. So that would be the sum of the two functions.